Again, hopefully some of this you've had a little bit from Algebra 2. I know if you had Miss White, she likes going through this stuff. Wow. How do you really feel?
Wow, way to get on recording, guys.
Yeah.
Okay. This is a sigma. That sign means summation. You guys make me feel bad that I brought it up. Stop. Okay. Anyway, that means summation. All it means is that you add something up. So, if I had something like that, this is the way it looks. What you have is you'll be given a kind of like a dummy variable. What this is kind of like your counter. So this is saying that you count from 1 to 5. And then each term, what you're going to do is you're going to add them together. So I'm going to take the first term. I'm going to add it to the second term. And I'm going to keep doing that until I get to the fifth term. So that's the definition of a series. This here so this is a series. This is summation notation. Now, this one right here that we just did, this is a finite series. Yeah, that means it has an ending. This one would be an infinite series. Now, if we take this and let's say that we take and we just find that's called a partial sum. So if you have an infinite series and you just find part of it, that's called a partial sum. And sometimes we do that just to figure out what does this infinite series actually add up to be, because we can't actually find infinite series. But if we find a whole bunch of partial sums of it, sometimes we can find a pattern and figure out what this infinite series is going to end up adding up to be. And I'll show you an example of that. Okay, so these are kind of our definitions. We haven't really done anything here. Just definitions, so whenever I use some of these words, you guys know what I'm talking about. So what you're going to be given for problems are some things that will look like this. So all you have to do is just list this out. So we're going from k equals 1 to k equals 5. So the first term would be 1 squared plus 2 squared plus 3 squared, and we just keep going until we reach the top number, which in this case is 5. And we just have to figure out what that equals. What does it equal? 55? Yeah, k is just your variable. I think it's called, maybe called a counter, or I don't know. I don't remember what it's called, and I guess your book defines it as the index. Okay, so for example 2, we do the same thing. It's just, I gave you an example. We don't always have to start at 1. So 2 times 3 minus 4 plus 2 times 4 minus 4 plus 2 times 5 minus 4 plus 2 times 6 minus 4. You guys are getting a little loud. So 2 plus 4 plus 6 plus 8. So 20. All right, and yeah. If you had subtract signs, what it would be is it would be absorbed into this, like you'd have a -1 at the beginning of it. Okay. There's some properties that can make these easier for you. Just realize these properties are shortcuts. I'm going to show you how they're shortcuts. If you don't memorize these properties, it's not the end of the world for you. Again, they're shortcuts. First one. Okay, if I have the summation of a constant, and let me show you an example of this, because a lot of times it's easier with an example.
Oh God, are we going to do something about everything equal to 20 or something like that?
What? Well, I mean, we could do this with 20. This will make it easier. That's what I'm saying. Let's say I do this of 2. So what this means is I take 2, so that's 1, 2, 3, 4, 5.
Two.
2. Okay, what's that the definition of? Nope.
5 times 2.
5 times 2. This is the definition of multiplication. So, what this rule says is if you have a summation of just a constant, what that is that's just multiplication. Now, what you have to do is you have to be careful with this. Notice that it has to start at 1. If it doesn't start at 1, you're going to have to use a little bit of thinking and figure out, what is the distance of this. You can still use this rule. You have to just think through how many of these C's am I actually adding up. So like if it goes from 3 to 6, so 3, 4, 5, 6. So I'm actually adding it up 4 times. So then I could take it 4 times 2. So just be aware of how that rule is written. Okay. So the second rule. What's their second rule? Okay. Okay, if I take a constant times something. So, again, let me write this out in a rule. I'm just using 1 to 5 because it makes it short.
Is that CA or C0?
CA.
Okay. Wait, exactly what that was representing.
C times some function. So, like, if I do this.
Oh, okay.
Okay, so if I wrote this out, that would be 3 times 1 squared plus 3 times 2 squared plus 3 times 3 squared plus 3 times 4 squared plus 3 times 5 squared. Now, notice since they're all multiplied by 3, what do they all have in common? 3. So, instead, what I could do now, it seems ridiculous after I've written it all out to write it like this, but remember, we're trying to create our property. Is since they all have a 3 involved, I could pull that 3 out into the front. So, that's another property of these. If you have some sort of function in here, and it's multiplied times a constant, you can move the constant out to the front. All it is it's your distributive rule. You have a number times a whole bunch of things added together. So this is what your distributive rule kind of looks like in summation notation. Okay, third one and the fourth one kind of go together, and I'm kind of debating on whether I want to give you 2 rules or just give you 1 rule. Okay, if I have 2 separate functions and they're added together, this is your associative rule, really. What it says is let me write a really short one down here because this is a lot of writing. we write 2k plus k squared. So that'd be 2 times 1 plus 1 squared. Plus 2 times 2 plus 2 squared. Plus 2 times 3 plus 3 squared. Okay, what this rule wants us to do is to regroup. What I want to do is take all the ones that are times 2 and put them together, and all the ones that are squared and put them together. Since these are all just parentheses, and since it's all just addition, I can do that.
You can do what?
All I'm doing is I'm just regrouping. I'm putting the squareds together and the multiplications together. Since they're all just multiplications, or I mean just additions. There's nothing in there except for addition in between things, right? And addition I can move around however I want to. So then this here this is the summation of 2k, right? Plus, this is the summation of k squared. So what this rule says is that, and again, all this is this is just your associative rule with addition. Since it's all addition, and it's all that the summation sign means, I can move my addition around however I want to. So I can regroup my additions so that all the A's are just added together and all the B's are added together. And then I can put the addition sign in between. Let me go ahead and write it out. I'm not going to prove it like I'm doing the others, because it's, oops, I missed the one thing that was important. You can do the same thing with subtraction. Okay, and like I said, the properties, I'm not going to ask you specifically to use any of the properties. Properties are kind of like shortcuts. They can make your work easier, especially with some of the work we're going to do in the next couple sections. They might come in handy, but they're not life-ending if you forget one of them or if you forget to use one of them. Yeah. Oh, okay. So I got 3 more examples. I'm going to go do 2 of them where we're going to use the properties, and then I'm going to do 1 of them where we're going to do an infinite sum. I'll show you how to do an infinite sum. Because you're like, you know, how do we add up something that we can never reach the end of? Okay, am I good? Yeah. On finals day. For you guys, it's on Tuesday.
Do we still have half day or is it still on
Full day. Schedule's up next to the door. Monday is a normal class day. Tuesday, Wednesday. Yes. Friday and Monday will both be review.
They can I just take draft for review?
I don't care. I just said not. You were talking like you wouldn't do it today or tomorrow.
Well, can I do that during class?
Yeah, you're fine. Okay, so this one, if we wanted to use our property, what we could do is we could take the 5 out. So then all this means is I need to add up the numbers 1 through 4 and then take that times 5. So that's 10 times 5, which is 50. So that's how we would use one of our properties.
Wait, hold on. So how do you determine K? Like, so we're trying to figure out what K is? Or?
No, K is the numbers 1 through 4.
Okay.
I just use the property instead of keeping it 5 times K and doing that each time. I could use the rule where I pull the 5 out to the front. So I only have to do the multiplication once.
So that's a general thing you can do for multiplication.
That was one of our rules that we just did. So on this one, I could split it apart like this using rules. So according to my rules, I can pull the 3 out to the front and I can separate them. It just, what it does is it simplifies the amount of calculations I have to do. So here I just need to take 2 plus 3 plus 4 plus 5. Here I need to take 2 squared plus 3 squared plus 4 squared plus 5 squared. So that's 5 plus 5 is 10 plus 4, that's 14. So 3 times 14 minus, this was 55 earlier where we had the 1, so now I'm going to assume that this is 54. Okay, so 3 times 14 is 42. So 42 minus 54. Negative 12. Now again, you could have done that entire one without using any of those properties. If I see you do it on the test without the properties, I'm not going to count you off. It's not going to bother me one way or another. The point of the properties is just to make your calculations a little bit easier, a little bit quicker. And make it so maybe you could do it in your head instead of having to use a calculator. Okay, infinite sum. Some of these we can do by doing partial sums. So, if I do the first partial sum, right here, instead of writing it like that, that doesn't make sense. What is A1? Well, A1 is 1 over 10 to the 1, which is 0.1. Okay, A1 plus A2 would be 1/10 plus 1 over 100th, which should be 0.1 plus 0.01, which is 0.11. Well, I can see the pattern, but just to make sure you see the pattern, let's do the third partial sum.
I know you can find the result of this. Like it's gonna be like some whole number like 20 or something.
No, 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 no. See, you haven't seen the pattern yet, Manny. You see the pattern yet, Manny? The the first the first thing I get is that whenever I add it the second addition, I get this. The third, whenever I add 3 terms together, I get that. What am I going to get whenever I add 4 terms together? So if I add 4 terms together, the fourth partial sum is going to be 0.111. The fifth partial sum is going to be 0.11111. So what is that? 0.1 repeating, which is equal to what? 1/9. Okay, so if I did this, what does that equal? Because that's going to take each of those terms times 3, right? So it's going to give you 0.3, then 0.33, then 0.3333, 0.33333. So you're going to get 0.3 repeating, which is 1/3. So now it doesn't work for all infinite sums to write out partial terms because trust me, it doesn't. Sometimes what they'll do is they'll alternate and they'll slowly, so one term you'll get a positive number, next term you'll get a negative number. And then you'll get a smaller positive and then a bigger negative. And they'll slowly alternate until they get to closer and closer to a number. And you may not get close to that number until the 10,000th partial sum. So writing out partial sums is not going to find you a pattern. There are formulas for that, and we will get to that. I think that's 9.3.
Mr. Collette, so I'm wondering, how do you know that's going to be equal 1/3?
Do this.
And here,
first partial sum is going to be that.
yes.
Second partial sum is going to be those two things added together, which is going to be 0.33. Third partial sum is going to be that. Fourth partial sum will be those things added together, which will be 0.3333.
So how would I be able to identify that is 1/3? Like, let's say if I didn't know.
No, you would have to know that because you're in pre-calc. You should know that 0.3 repeating is 1/3.
Oh. I don't know this, though. I wasn't taught this.
That's prior knowledge. I'm assuming you know.
Shoot. How can I learn?
Don't know. There's certain repeating fractions that we're assuming you know.
That sucks.
I mean, I'm not going to give you weird ones, but some of them, like 0.1 repeating and 0.3 repeating.
I'll just type it in my calculator.
Okay, there's your homework. And again, if it helps you, Manny, by the time we get to the test, you will have a formula to figure these out.